just a little bit about me. My name is Nikolai Volodkin. I'm a senior solutions architect here at Sauce Labs, and I've been here for over 3 years now. It's really, I think, all that's important. Most importantly, I think, is that I'm an animal lover, so you have to trust anything that I say. So I want to start out this presentation by having all of us play a little game.
This is the shell game. I'm going to hide this Hershey's Kiss under this cup, and the object is for you to pay attention and follow along and try to guess which cup the Hershey's Kiss is under at the end. Try to guess if it's in the left cup, the middle cup, or the right cup. Let's check the left cup. The middle cup? If you guess the middle cup, you got it right. So now we're going to make it a little more complicated. I've added an extra pair of hands and I've added additional colors here. But that's only to distract you from the pink cups. One of the pink cups will always have the Hershey Kiss underneath. So let's get started. So can you guess where the Hershey Kiss is?
The purpose of that game is to basically tell us, everyone understands from your testing experiences, that our human eyes can miss a lot of important information, especially when we're focused on a specific task. We don't notice things outside of that task. You were maybe doing a functional test. We obviously are not paying attention to any other elements that may be going wrong on the page. So that brings us to some visual errors that have happened in real life. I'll give you guys some quick stories. This one is kind of crazy. It talks about basically how in Soviet Russia, there was this guy called Petrov. He was monitoring a nuclear missile panel, and the missile panel started going off, saying that there's missiles being launched at the Soviet Union from US. Luckily, he was able to use his brain and figure out that this is an issue, and it's not an actual nuclear event happening. So he didn't launch nukes back at us, avoiding a nuclear holocaust. Not as serious, but also significant, is on a Southwest website. This button you can see was covered up by this text. Southwest earns like $2.5 million per hour from their website. So even if this visual bug was on the website for a short period of time, you can imagine that it cost the company lots and lots of money. Even less significant, but still important, is an example of my website, which I developed in a nice 1080p resolution. But whenever it was scaled down on a smaller resolution, you can see how weird stuff starts to occur, where my text was overlapping with each other. My search icon was starting to go down and be in the wrong place. And it's very common in responsive applications. So how do we prevent such kind of issues? Well, that's why we're all here, is for visual testing. Visual testing is basically ensuring that our application appears as we intend it to appear. It's a mix of functional testing and manual testing, but different in that we're not validating, like, can I click a button or can I fill out a form and submit a form? Instead, we're pulling up a page or a component of a page and ensuring that it meets whatever visual criteria we have for that. And then we set it as a baseline. And once it's set as a baseline, every future execution of that visual test will check against that baseline and will identify any visual differences that have happened in the new iterations of the application. So let me show you all how everything actually works. So I got this solution here written in .NET and .NET. So I'm gonna run some tests. I have them called as visual tests. We'll let those run and I'll take you guys to the screener UI while those are running. So inside of here, what you'll see is a bunch of projects on the left-hand side. You can think of a project as basically an application. I'm calling our project Sauce Demo C#, but you may call it obviously whatever you want. As it's running, it shows all of the different types of all the tests that are running. It's showing the resolutions and the names of the tests here on the right-hand side. A previous execution of this test that I did right before is here. It shows that we ran and 10 tests were accepted. So if we click here, we can see that these are all of the screenshots that were previously captured by our tests. And what you can see here is they're on different device resolutions, right? So here, this resolution is on Safari Mac OS, representing an iPhone X. This one is on a Pixel XL, for example, and so on and so forth. And we are capturing each page and then checking it for visual discrepancy. So on the left-hand side, you see a previously accepted version of the page that I've captured. If we come here, we can actually see its entire history. We can see long ago, I captured the baseline for this application. And ever since then, this is what keeps getting checked against our current state, which looks like this. Let me close this. So because there are no visual discrepancies, there's nothing much to see here. We can go page by page and see that there's nothing really that has changed. And so our visual end-to-end testing tool doesn't show any differences. However, if there were differences, they would look, they would look something like this. So you can see in this case, we've executed 254 snapshots in 1 minute and 49 seconds. So that's one of the major advantages of visual testing, is it's not only extremely fast, but it's extremely reliable, meaning that we're probably used to some flakiness, false positives with our functional test automation. With visual, it's basically non-existent. And so it shows that we have 4 changes and another 250 we've previously accepted that have not changed. If we come here, we can see what has changed. And here, for example, you can see our previously accepted. Here's our current version of the application. And in this case, we see that previously this button was on the right-hand side. Now it's moved over to the left-hand side. We can come here and even see those changes. So it tells us that there's a layout change and a style change that happened to this button, describing what's happened over here. We can choose to ignore this change if we desire. Now, ignoring a change may be very valid in some instances where maybe you have like a banner in your application that display some kind of a message that changes week after week, right? Maybe you're having a sale and that sale is going to disappear next week, or maybe you have a calendar that changes a date. And so in that case, you can come over here and you can choose to ignore that element or that component so that in future iterations, Screener doesn't actually identify it as a change. You can do that manually here by clicking this button, or you can do it through code as well, simply by passing in the element locator whenever you do your visual snapshots. I'll show you guys a little bit about that in a moment. We can do it through code as well. Then, and again, doing it through code would be beneficial. Let's say for example, if our header was dynamic and had some dynamic content here, we can just choose to ignore that header for all of our tests, making our life easy. And if there were any changes, Screener wouldn't identify it. Let's take a look at some other changes here. You see kind of similar change. Here's a little bit of a different change. You can see that it tells us that the color, the background color changed of this button. And it's also telling us that there's a content change, which it tells us it went from a 1, which is in red, it means it was deleted, to a 2, which is in green. And then most importantly is this kind of change where you can see that this component here was actually removed. And so Screener uses what's known as a visual hybrid diff, which is a smart algorithm that uses changes in the DOM as well as visual changes to actually determine what's happened to the application. So many different visual tools would see this and they would identify the entire thing as changed because obviously every element in here has shifted up. However, because of the smart hybrid diff algorithm, Screener is able to figure out that only this element was deleted and hence everything else was shifted up, but this is the only thing that it identifies as a change. And then we can see here, that's the only change that has happened. If we, for example, decide that this right here is the new version of the application that we desire to use moving forward, we simply have to come here and say accept. And now this new version of the application is going to be the new baseline that's used for checking for every future execution of this test case over here. Let me see if there's anything else that's important to see. Oh, you can, of course, see all the results if you want here. You can do filtering up here, right? So here now I'm seeing all the accepted ones, which are not typically very useful to look at because they don't have any data. If you are not happy with a change, you can always reject it and say, oh, this was not supposed to happen. You can always reject the change. And so now you have to go back in your application, resolve the discrepancy, and now a new execution, you'll need to rerun your test. And then at that point, you can make the appropriate decision about whether to keep the baseline or not. Let me show you all some other important stuff here. The docs here are very useful. You just come here and go to Visual End-to-End Docs. It'll take you through a bunch of different information that you can look at. A very common question I get is, what are the supported browsers? Here is everything that Visual End-to-End currently supports. So the browsers and the operating systems. And then of course you can pass in any type of resolution that you want. And there are visual options that you can set. There's many different kinds of things you can do. Here's an example of some diff options that you can set. You can ignore elements at the entire test level, many kind of options that you can set here. And then there's also some visual commands. I'll actually take you to those in the code. This repository is publicly available, so I'll share it with you all afterwards. And actually here we have a best practices kind of example that was written by me in order to show how to do different types of tests in a single library. It does mobile and web automation on desktop, real devices, MESIM, and it does visual testing, accessibility testing as well, all in kind of in one source code. And so here, let me take you guys through these visual tests here. The very first thing that's important to notice is that I am using this test fixture source to run across what I'm calling popular visual resolutions. If we navigate here, here is the information that I'm passing in. running either on Safari options or Chrome options in different resolutions, and I'm giving them an appropriate name that will tell me which device these resolutions correspond to. The setup, we have our sauce options, which take the standard username, access key, test name, not mandatory, but highly, highly recommended. And then to hook into Screener, we set visual options. So you can see here, we got visual options, getting in the Screener API key, which, oh, sorry, scrolled the wrong way. Screener API key you can find here in your account. And then you click API key, and then it'll take you to a page where you can capture that. Make sure you save it in your environment variable. So these two are mandatory here, API key and project name. Project name corresponds to, you can see here, I have sauce demo C#. That corresponds to this right here in the dashboard. So you can see if you click all project, you can see sauce demo C#. And then viewport size, I'm saying, because if this is a demo, I'm saying don't fail on new states, which means that whenever you first execute a visual end-to-end test, Screener doesn't know or any visual testing tool doesn't really know what to do with that image, right? Is it a good image or is it a bad image? We don't know. It's up to you to decide. And so everything starts out in a new state. Let me see if I have something here in a new state, just to show you. Here. So you can see it would look something like this. You can see that I have 8 new snapshots that Screener has never seen before. And here's an example. And so it says, hey, what do you want? Is this a valid snapshot? Do you want to accept it? And so then in that case, you'd come here and accept, setting a brand new baseline. If you know that all of these are good, you can accept all of them at once and say, okay, all of these are good. I am going to accept all of them, and now they'll all be a baseline. However, for my demo purposes, I am saying don't fail because I want my test to pass. And then let me show you all how we actually do the visual testing, which is actually relatively easy. So we're just using a JavaScript executor. And whenever we're starting a test, we run this visual init command. And then we're passing in what I'm calling the device name. That corresponds to this guy right here. Okay. And then we navigate page by page. You can see I have a login page here. For example, I'm visiting. And then the only extra thing that needs to be added is this take snapshot command. That's another JavaScript executor command that I wrapped. Looks exactly like this. You just call this command here, and then you pass in any string that you want here. I'm passing in the page object name, making it really easy and nice to look in the UI. And that's how we get a dashboard that looks like this, where you can see here it says iPhone X login page, iPhone X products page. I highly recommend that everybody follow a similar workflow. It just makes it very easy to identify everything in the UI. And then at the very end, you call this visual end command. It will stop your session, and then it will check that whether there are any discrepancies. And if there are, it'll come back as an object into here, and then you'll have a bunch of messages that'll say you have 1 or 2 or multiple visual discrepancies. And hence here, I'm asserting that it should be null, because if it's null, it means that everything was successful. In terms of technical stuff, the documentation has everything covered. It's like, if you have a question, how do I do X? How do I do Y? The docs have you covered. In terms of like implementation, some tricky situations customers get into is a page has to be in a good state before you can capture snapshots. So what I've seen customers struggle with is, number one, loading time. Sometimes they don't allow the application to fully load before capturing a snapshot. We've introduced some logic into Screener that now should make it easier, but I have still seen customers that try to capture a snapshot before the page is ready, and then they get a weird looking snapshot. So just make sure you allow enough time for the page to load. Another one is if you have a page with like lazy loading, for example, where elements don't load on the page until you scroll through them. For example, like my website has lazy loading. If I captured a snapshot, like a bunch of stuff below the fold doesn't actually load, and until you scroll over it. See how it does that? And so there, what you would want to do is scroll down to the page and then scroll back up and then capture the snapshot. And then that typically solves most of customers' problems. It does. Yup, I actually haven't played with that code, but here, let me visual commands, it's visual options. So here's, it says it's a beta feature. I know it's been a beta feature for a while. So give that a shot. I need to give it a shot myself to see how well it works. This is, in my opinion, one of the best use cases of cross-browser, cross-device parallelization is for visual testing, because for web apps, the most common thing that goes wrong is when we have different resolutions, things start to shift, and then things may start to look weird. And so you can see how I implement that here. I use NUnit because NUnit allows parallelization at the class level. And then you can see I'm passing in popular visual resolutions here. So that's how I'm configuring that. And then each one of those is a brand new test that runs in parallel across this logic right here. So it's going to execute these 1, 2, 3, 5 browsers and resolutions for this one test, and then keep capturing snapshots. It's hard for me to say an average. At my previous workplace, I was doing 3,000 to 9,000 visual validations every 2 weeks. At my previous project, we had an assessment application where it was statistically important to make sure that the application looks the same for everybody, because it could affect people's scores. And so capturing a snapshot of every single one of the pages was very business relevant. And so that's what we did. We captured all the snapshots as often as we could. We do that like on a daily basis. I think many businesses don't have all the pages that are like very important, right? Maybe like a contact us page is not as important as a home page for your guys' web application. So if you're finding that you're getting feedback fast enough from all your testing, then keep running all of it, because there's no real disadvantage to it. But if you're finding that at some point you're doing too many snapshots and you're getting bottlenecked in terms of your feedback, or it's taking too much time, maybe you now want to parse out the pages that are important versus not so important. I like personally to run all my tests as frequently as possible. I run them on every commit. I run all my tests, but they give me back feedback in like under 5 minutes, or like all my hundreds of tests. And I'm happy with that. You know, if I find that it becomes too slow, at some point I'll need to start quarantining tests that aren't as relevant. Here's a page object. It extends my base web. So this is a login page. So it's going to have everything relevant to the login page, such as the login method, which does a bunch of stuff. That inherits from a base web page, which has our driver that's reused in all of the objects. Here I'm defining a base URL for the application. I have my JavaScript executor that's used all over the place. I have a expected conditions wait class that allows me to easily perform wait operations, like all the expected condition stuff. Just to give some examples, wait until it's visible by class. Some of them obviously I'm not using, get rid of it. And then I have a take snapshot method as well, which all of my page objects use for visual testing. I'll probably move it somewhere else because not all of my page objects need a take snapshot method, but we'll see. I need to maybe refactor it now. You guys can't add that logic to your existing tests. However, you can create a new class and create a new driver instance, and then repeat the logic that you previously have had, but just now being able to do visual capabilities. You just can't plug into your existing tests, but just create a new driver, point to the right hub, and then reuse your functionality that you already have and just take snapshots of those pages. The best way to capture snapshots is just go page by page by page, capture all your, and just keep taking snapshots of every single page, and then just do it on all the browsers and operating systems that you want. And that's what I recommend for everybody, because that's usually where most of the discrepancies happen, is when our responsive applications are resized, and then that makes our elements weird. So just pick whatever is most relevant to your guys' business. You don't have to capture it on all the browsers and operating systems, right? At some point, there's more noise than there is value coming from our tests, but find out what's most important. Obviously, like iPhone resolutions, Android resolutions, those are important. A few desktop resolutions, and that should be sufficient. So this is actually known as a viewport size. A viewport size is different than a resolution. So if you wanted to determine, iPhone viewport size, I know there's a table that shows it here. And here you can see, for example, all the different viewport sizes. So it's obviously different than a resolution, but this is the viewport size. That's what you use to capture the snapshots. This is what a user actually sees, as opposed to this guy.